So, at this point we have two equations. Now, if you think about this equation, the only dependent variable is x, and in this second equation the only dependent variable is t. So, in some sense what we have is two ordinary differential equations, and this is a second order ordinary differential equation with constant coefficients, and the second equation is an ordinary differential equation, but this is a first order ordinary differential equation with constant coefficients. Okay, so the next step is to use the techniques that we learned in the first part of the differential equation course and solve these two equations. I am going to consider equation 1. So, let us say x double dot plus lambda x equals to 0. Now, this lambda is an unknown constant. So, lambda can be a positive value, lambda can be a negative value, or even lambda can be 0. So, next we are going to analyze those three cases separately. First, I am going to consider, see, this is case 1, lambda equals to 0. So, now I am going to solve this equation for lambda equals 0. If lambda equals to 0, this equation becomes x double dot equals to 0. Okay, so let us solve for x. We have to integrate this one twice. So, if you integrate this equation once, you will get x dot equals to some constant, let us say a1, and then if you integrate this one with respect to the x variable again, you will get your function x equals to a1x plus another constant of integration b1. Okay, so, this is your x of x, which is a1x plus b1. Okay, the second case is, okay, let us say case 2. So, now we are going to consider negative values for lambda, and let us say lambda equals to negative a squared. A squared is a positive number, but we are going to multiply this positive number by a negative quantity or negative 1, then lambda is a negative number. Okay, so, then our equation becomes x double dot minus a squared x equals to 0. So, next we are going to solve this second order ordinary differential equation with constant coefficients.